The June heat over Rome shimmered across the tarmac of Guidonia Airfield. The air buzzed faintly, part from cicadas, part from the lingering energy of the captured aircraft standing before the Italian engineers. The machine gleamed in the sunlight, an American fighter unlike anything most of them had ever seen. Its twin booms stretched behind a slender central pod that looked oddly unbalanced to Italian eyes. Even grounded, it radiated a kind of mechanical confidence. Filippo Zapata stood motionless for a long moment before approaching. As the senior propulsion engineer of the Regia Aeronautica, he had examined many aircraft during the war, from nimble Spitfires to rugged German designs. But this was different. The markings told the story immediately. White stars within blue circles, bold and unmistakable. A Lockheed P-38 Lightning. Captured intact after an emergency landing in Sardinia. Both engines still operable, both fuel tanks undamaged, both propellers unbent. It was a miracle of fortune, and a window into a world of engineering that Italy could barely imagine. His assistants whispered as they circled the aircraft. To them, it looked ungainly, even awkward. Italian design was known for balance, grace, and clean form. This, by contrast, seemed overbuilt, heavy, excessive. Twin engines where one should suffice, double tails instead of one elegant fin. Illinois Diavolo a due code, someone murmured, the two-tailed devil. The group laughed quietly. But Zapata didn't. He studied the aircraft's long wings and perfect seams. He saw no wasted space, no handmade inconsistencies. Every rivet line was straight. Every curve served a function. The Americans hadn't built it for beauty. They had built it for reliability. He felt a strange unease. On paper, the P-38 weighed nearly twice as much as Italy's finest fighters, the Macchi C.202 and Fiat G.55. Yet it could climb faster, fly farther, and carry heavier weapons. The numbers made little sense until you looked closer. And now he could. Open the access panels carefully, he ordered. The team obeyed, laying out their measuring tools, notebooks, and cameras. Zapata circled slowly, noting dimensions, inspecting the tricycle landing gear, the thick wing spars, the heavy aluminum skin. 18,000 pounds, one of his assistants muttered after calculating the loaded weight. It should fall out of the sky. Zapata gave a tired smile. Then let's find out why it doesn't. As the inspection continued, he began to see the first pattern, not in any single component, but in the philosophy behind the entire machine. The P-38 wasn't elegant in the traditional sense. It was logical, purposeful. Every part existed to make the aircraft stable, survivable, and powerful. Where Italian engineers trimmed every gram of metal to chase speed, the Americans seemed to build strength first, then add power to overcome the weight. It was a completely different way of thinking. When they finally reached the engine nacelles, Zapata hesitated. Let's start with the left side, he said quietly. The men unlatched the cowling panels and lifted them free. Beneath lay the beating heart of the aircraft, the Allison V1710, a massive 12-cylinder V-engine unlike anything built in Italy. The metallic scent of oil and heat lingered in the air. One mechanic whispered, "It looks like something from a factory, not a workshop." Zapata nodded. Exactly. It was never handcrafted. It was manufactured. He leaned closer, tracing the lines of tubing, the intercooler ducts, the complex network of exhaust pipes leading backward along the boom. Something about the layout caught his attention immediately. A turbine, small, compact, and connected to the exhaust flow. Zapata froze. He had read reports of such systems in American aircraft, but few had believed them. Turbochargers, using the energy of exhaust gases to force more air into the engine, maintaining full power at high altitude. Germany had prototypes. Italy had blueprints. But here it was, real, functional, and mass-produced. For a moment, no one spoke. They just stared at the gleaming turbine housing, the precision of its machining, the smooth welds that could only have come from automated tools. Zapata ran his finger across the metal, then stopped. "This isn't just an engine," he said quietly. "It's a statement." He took out his notebook and began sketching. Dimensions, airflow paths, temperature estimates. His assistant, Mancini, crouched beside him. "Could we build this?" Zapata didn't look up. "With our facilities? No. Not like this. Maybe one prototype. But not hundreds. Not every month." The sun was sinking low by the time they finished documenting the left engine. The aluminum gleamed gold in the fading light. The numbers in Zapata's notebook already told him what he feared. Each turbocharged engine could produce over 1,000 horsepower at altitude, nearly twice the output of Italy's best designs. Two of them together gave the Lightning a combined thrust that no Italian or even German fighter could match at high altitude. He closed his notebook slowly. The realization settled in like a weight he couldn't shake. They are fighting this war with mathematics, he whispered to himself. And the math isn't on our side. The team packed their tools as the guards prepared to escort them off the field. Zapata looked back one last time at the captured fighter, its twin tails silhouetted against the evening sky. It no longer looked awkward. It looked inevitable. Tomorrow, they would open the right engine. Tomorrow, the truth would become impossible to ignore. Morning light spilled across the airfield as Zapata's team returned to the captured Lightning. The air was crisp, filled with the faint metallic scent of oil and dust. Guards stood at a distance while the engineers laid out their instruments once again: calipers, micrometers, notebooks, and rolls of thin measuring tape. The aircraft waited in silence, its silver fuselage glinting as though mocking their curiosity. "Let's open the other side," Zapata instructed. The right engine cowling came loose with a click of latches and a hiss of displaced air. Beneath it, another Allison V-1710 gleamed like a polished sculpture, not because it had been cleaned, but because it was made with a precision so fine it seemed deliberate in every detail. The bolts were perfectly aligned, the pipe symmetrically curved, and the components arranged with mechanical grace. His assistant, Mancini, bent down, brushing away a bit of sand. "It looks more like a laboratory experiment than a combat engine." Zapata nodded slowly. "That's because it was designed by a nation that treats its factories like laboratories." He examined the turbocharger again. Twin units, one for each engine, connected through a maze of ducts. The exhaust lines flowed backward along the booms to spin the turbines, feeding compressed air forward into the engines. The system was complicated but elegant. Nothing seemed wasted. No space, no motion. "Every other country tried to make this work," Zapata said. "The Americans made it routine." He crouched down to inspect the turbine wheel. The blade shimmered faintly, revealing an alloy that was unmistakably special. "This metal," he murmured, "is not ordinary steel." He tapped it lightly with a wrench. The tone was high and resonant, too firm for standard alloys. "High nickel content," said Russo, their metallurgy specialist. "Maybe chromium too. Whatever it is, our factories couldn't forge it. Not at these temperatures." The turbine, Zapata realized, was the true miracle. It endured temperatures exceeding 700 degrees Celsius, spinning at over 20,000 revolutions per minute, a mechanical heart pulsing faster than anything built in Europe. Italy had the theory. Germany had prototypes. But America had the means to turn theory into production. He began calculating the power output again. Each engine produced roughly 1,100 horsepower at altitude, 1,250 under emergency conditions. Combined, the aircraft could deliver over 2,800 horsepower, enough to lift 18,000 pounds of metal, fuel, and ammunition into thin air. A Macchi C.205 makes 1,075 horsepower, Zapata muttered, pencil tapping against his notebook. But only near sea level. By 20,000 feet, it can't breathe. Mancini tilted his head. "And this one?" Zapata looked up. "This one breathes all the way to the stratosphere." The next hour passed in silence except for the scratching of pencils and the faint ticking of cooling metal. They recorded gear ratios, bearing sizes, and manifold diameters. The deeper they went, the more the design philosophy revealed itself, not genius in complexity, but in systemization. Every piece could be replaced easily. Every screw was standardized. The Americans hadn't built an engine for artisans. They had built it for workers on an assembly line. When the inspection reached the propeller system, Zapata's expression darkened again. Counter-rotating blades, the left turning one way, the right turning the opposite. He turned to Russo. "You understand what that means?" Russo exhaled slowly. "They've eliminated torque entirely." It was the kind of refinement Italian engineers dreamed of, but never achieved. Two separate reduction gear systems, mirror images of each other, synchronized to balance rotational forces perfectly. The gears themselves were hardened steel, precisely cut to tolerances within thousandths of an inch. "Our steel would shear under half this load," Russo said, voice flat. Zapata didn't reply. He just kept writing. His notes no longer described individual parts, they described philosophy. The Americans built for endurance, not delicacy. Their machinery was not the expression of a craftsman but of a system, one capable of endless repetition, consistency, and scale. After several hours, they moved to the wing roots. There, they discovered the cooling system, liquid radiators built into the wing leading edges. The idea alone made Zapata pause. Italian fighters carried radiators externally, where airflow was uneven and damage was common. The Americans had hidden theirs within the wing, a perfect balance between protection and efficiency. The radiator cores themselves were marvels of miniature precision, hundreds of tiny tubes, brazed with immaculate accuracy. If we made radiators like this, Mancini said quietly, we'd spend a month building one. Zapata shook his head. They build hundreds every day. As they continued, the list of technological surprises grew: redundant fuel lines, twin generators, double hydraulic pumps, armored conduits for critical systems. It was not a plane built for elegance. It was built for survival. When the sun dipped lower, they finally closed their notebooks. The hangar lights flickered on, bathing the lightning in a soft glow. It stood there like a metallic animal, silent but ready, daring anyone to question its design. Zapata lingered as the others packed up. He placed one hand on the fuselage and whispered, almost to himself, they didn't build this to impress engineers. They built it to outlast wars. As he walked away, he couldn't stop thinking about the numbers, the horsepower, the alloys, the precision. Each value pointed toward an invisible truth that grew clearer with every measurement. The Americans weren't just ahead in design. They were ahead in everything that made design possible: material science, machining, production, logistics. Tomorrow, he would begin drafting his report. But tonight, for the first time in his career, Filippo Zapata felt something he had never felt before while standing beside an aircraft. It wasn't admiration. It wasn't envy. It was inevitability. By the following morning, Zapata's office was filled with sheets of sketches, rough calculations, and long columns of numbers. Every figure told part of a story of precision, capacity, and scale. He had spent his entire career believing engineering was about cleverness, about making more from less. But now, as he reread his notes, he realized that cleverness could not substitute for capacity. He began assembling his findings into coherent sections: propulsion, cooling, structure, systems. Each one presented the same pattern. The Americans had built not only a powerful aircraft, but an entire ecosystem around it: factories that could produce identical parts by the thousands, alloys capable of withstanding forces Italy's foundries could barely imagine, and machining tolerances that reduced human error to almost nothing. The first section focused on the engine. 2 Allison V1710s, 12 cylinders each, 28 litres of displacement, producing 1,125 horsepower apiece. Each engine alone was a masterpiece of industrial confidence. The turbochargers kept power stable even above 25,000 feet, while the counterrotating propellers balanced torque so completely that the aircraft felt smoother than any single-engine fighter. The combination produced over 2,800 horsepower, more than double what most Italian fighters could generate even under ideal conditions. Zapata compared this to the Daimler-Benz DB605, the power plant used in Italy's best aircraft. On paper, it was comparable in size and output, but its performance plummeted at altitude. The Allison, by contrast, climbed effortlessly. The difference wasn't just design. It was metallurgy, manufacturing, and the simple fact that America could afford to build each component to perfection. He scribbled a note to himself: to equal their engine, we must first equal their factory. The second section described the cooling system, a feature that continued to astonish him. The Lightning's radiators were integrated into the wing edges, invisible to the eye but remarkably effective. The design reduced drag and improved durability, while the coolant mixture operated at higher temperatures than anything used in Italian engines. They solved problems we didn't even have names for, Zapata muttered as he wrote. And they did it in production quantities. Then came the electrical and hydraulic systems. The Lightning used a 24-volt network with redundant generators, ensuring that even if one engine failed, all systems would remain active. The hydraulics that powered the flaps and landing gear included secondary pumps and pressure lines. Italian fighters, by contrast, used simple mechanical systems or single hydraulic circuits vulnerable to even minor damage. The more Zapata analyzed, the clearer it became that the Americans built redundancy into everything. Their approach to aviation wasn't art, it was insurance. They designed every system so that failure in one area wouldn't doom the aircraft. And they could afford that, not because their engineers were more imaginative, but because their factories could build complexity at scale. Next came the weapon systems. When he first saw the armament specifications, Zapata thought there was a mistake. For Browning .50 caliber machine guns and a 20mm cannon, all concentrated in the nose, with 2,000 rounds of ammunition. He recalculated twice, then 3 times. It was correct. Italy's most heavily armed fighter carried less than half that amount, distributed across the wings, meaning its accuracy dropped with distance. The P-38's guns were perfectly aligned, delivering a single, focused stream of fire. Point, shoot, destroy, he wrote in his notes, simplifying the entire doctrine in 3 words. By noon, his desk was covered in paper. The numbers no longer just described an airplane. They described a philosophy. American design didn't chase beauty or weight savings. It chased control, predictability, and standardization, principles that turned engineering into mass production. Zapata leaned back, staring at the ceiling. The arithmetic of war had never been clearer. The P-38 represented not only advanced engineering but the industrial muscle behind it. For every one of these aircraft Italy examined, America could build 200 more. The math was merciless. He opened a new notebook and began drafting what would become the strategic assessment section of his report. The words came slowly but steadily. The Lockheed P-38 represents a level of aeronautical sophistication approximately 5 to 7 years ahead of Italian capabilities at our current rate of progress. Its engine, structure, and systems cannot be reproduced by our industry with available materials, manufacturing precision, or supply chains. He paused, then added, production of a single prototype equivalent to the P-38 would consume the resources required for 20 standard fighters. Attempting to match this aircraft technologically is impractical within the foreseeable future. He stopped writing and stared at that sentence for a long moment. It sounded defeatist, and he knew it. But he also knew it was the truth. He continued, Italian aviation must adjust doctrine accordingly. Direct confrontation with this class of aircraft should be avoided when possible. Tactical emphasis should favor speed, maneuverability, and lower altitude operations. The P-38 strengths are found at altitude and in sustained engagements. Its weaknesses, if any, lie only in its cost and maintenance, factors irrelevant to us under current conditions. The report was becoming more than a technical document. It was a confession, an acknowledgement that the future of warfare had already changed, and Italy had no means to follow. Zapata rubbed his temples. He felt the fatigue of realization, not from physical work, but from the weight of numbers that refused to lie. The Americans had turned industry into strategy. They had turned factories into weapons. He closed the notebook, placed his pencil down, and looked once more at the hangar through his office window. The lightning sat there, still and silent, but somehow alive, the embodiment of power that no single invention could counter. In that moment, he understood something that engineers rarely admitted aloud. You can't outdesign an empire that outproduces you. And for the first time, he began to see the war not as a battle of courage, but as an equation already solved. The following morning, the air at Guidonia shimmered with heat as word spread that the captured Lightning would fly. Mechanics rolled the silver aircraft onto the runway, its twin tails gleaming in the Italian sun. Pilots and engineers gathered at the edge of the tarmac, murmuring quietly. For them, it wasn't just another test. It was a chance to see whether the numbers in Zapata's report could come alive in the sky. Colonel Angelo Tandy arrived shortly after sunrise. His reputation preceded him, Italy's most experienced test pilot, a man who had flown everything from fragile biplanes to the latest Macchi fighters. He carried himself with the calm confidence of someone who had seen the limits of both man and machine. When he approached Zapata, the 2 men shook hands silently, both professionals, both aware of the stakes. "I've read your notes," Tandy said, adjusting his gloves. "You make this thing sound like a miracle." Zapata didn't smile. "Miracles don't come from machines, Colonel. They come from factories." Tandy chuckled softly, but his eyes remained on the aircraft. "Then let's see what kind of miracle their factory built." He climbed into the cockpit with the ease of habit, scanning the unfamiliar layout. The dials were arranged logically, the labeling clear even in English. Everything about the controls felt deliberate, ergonomic, efficient, designed for pilots who might have only months of training. Zapata watched from below as the canopy closed with a sharp metallic click. The ground crew stepped back. Tandy pressed the starter switches, and the left engine roared to life, its propeller spinning in a low growl that quickly settled into a steady hum. The second engine followed, counterrotating in perfect synchronization. The twin sounds blended into a deep, even resonance that vibrated through the concrete beneath their feet. The Italian mechanics exchanged uneasy glances. They were used to the uneven purr of radial engines, the quiver of vibration. This was harmony. Zapata stood near the control tower, notebook in hand. "Notice the tone," he murmured to Mancini beside him. "Perfectly balanced frequencies. That's what counterrotation does. Cancels torque, cancels noise, cancels stress." The aircraft began to roll. Its tricycle landing gear moved smoothly over the tarmac, nose slightly lowered. Italian fighters typically bounced and shuddered on takeoff. This one glided. It reached the end of the runway, paused, and then, with both engines surging, began its run. At first, it seemed slow to gather speed, heavy, deliberate. Then, at what seemed like an impossible moment, the nose lifted, and the lightning rose cleanly into the air, climbing at an angle so steep it drew gasps from the crowd. Within seconds, it was a silver cross against the blue sky. Zapata's pencil hovered above his paper but didn't move. There was nothing to write. The performance spoke for itself. The P-38 climbed higher, circling over the airfield before disappearing briefly into a bank of thin clouds. The sunlight flashed off its twin tails as it turned, diving slightly, then climbing again with effortless precision. Every movement was smooth, stable, no sign of strain or wobble. After 15 minutes, the Lightning descended. Its landing approach was steady and controlled, the nose wheel touching first, then the mains, with barely a puff of smoke from the tires. The engines throttled down, and silence returned, broken only by the faint ticking of cooling metal. Tandy remained in the cockpit for several minutes. When he finally climbed down, his expression was unreadable, calm, but with an intensity that made the onlookers fall silent. He walked straight toward Zapata. "Everything you wrote," he said quietly, "was correct." Zapata tilted his head. And you understated it." He looked back at the aircraft, his eyes tracing the lines of its fuselage. At altitude, it doesn't lose power, it gains character. The climb rate is absurd. The controls are heavy, yes, but perfectly balanced. Visibility is outstanding. I tested the guns, a single burst from the nose. It's unstoppable. He hesitated, then added, "At 25,000 feet. It was still accelerating. Nothing we have can reach it up there." Mancini, standing nearby, asked, "Not even the new Macchi?" Tandy shook his head slowly. "Not even close. The Macchi dances. This machine commands." For a long moment, no one spoke. The realization hung heavy in the air. Finally, Zapata asked, "Could we build something to match it?" Tandy's answer came after a pause. "We could build one. Maybe. But by the time we finish it, they'll have built 500 more." He turned toward the horizon, where distant thunder from another Allied formation echoed faintly. "You know what's strange, engineer? The Americans built a machine that feels alive. It doesn't fight the air, it owns it." Zapata said nothing. His mind was already racing ahead, calculating production figures, supply lines, industrial capacity. Italy's entire monthly fighter output barely reached a fraction of what the United States produced each week. The comparison was more than humbling. It was final. That evening, the engineers gathered in the mess hall, speaking in low voices. The day's flight had erased any doubt. The P-38 was not just an aircraft. It was a message, written in aluminum and horsepower, about what modern war truly meant. Zapata stayed silent most of the night, staring at his untouched meal. When he finally spoke, it was barely above a whisper. "They have factories that think faster than our engineers." Mancini frowned. "Factories don't think." Zapata looked up. "These do." He wasn't exaggerating. The Americans had turned industry into intelligence, a system that learned, scaled, and perfected without pause. The P-38 wasn't a triumph of a single mind. It was the product of thousands, united by a process Italy could not imitate. Outside, the night air cooled. The Lightning rested in its hangar, silent once more. But for Zapata, It no longer seemed like a captured machine. It felt like a prophecy, a glimpse into a future that had already arrived. By dawn, Zapata was already back at the hangar. The P-38 gleamed beneath the rising sun, its surface beaded with dew like a sleeping predator waking from rest. Around him, the airfield was quiet except for the distant hum of generators. Most of his team hadn't arrived yet, but he couldn't wait. He needed to keep dissecting the machine that had rewritten everything he thought he knew about engineering. He started with the landing gear, crawling beneath the fuselage with a flashlight. The mechanism was a maze of hydraulic pistons, braces, and seals. Yet, despite its complexity, every component was arranged logically, built for speed of maintenance. "You could replace the entire assembly in an hour," he muttered, taking notes. "Our designs require half a day." Each nut and bolt was standardized. No handcrafted parts, no improvisation. Precision by repetition. When Mancini arrived carrying fresh paper rolls, Zapata pointed toward the exposed wheel wells. "Do you see this layout? The hydraulic lines run in parallel. 2 pumps, separate circuits. If one fails, the other continues." Mancini nodded, whistling softly. "Redundant systems in a fighter? That's insane." "Not insane," Zapata corrected. "Industrial." He stepped back, wiping oil from his hands. "They can afford to think this way because they build in quantities where failures are expected. If 10 aircraft fail, they still have 900 left. We build 30 a month, and every loss is a disaster." He opened the access panel to the electrical system next. Inside, the wiring looms were meticulously bundled, color-coded, and marked. It was an engineer's dream, and a factory worker's miracle. 8 miles of wiring, Zapata read from his earlier notes. And yet no confusion. They designed it for people who might never have built an airplane before. Mancini frowned. "You mean?" "Yes," Zapata said. "For a workforce trained in weeks, not years. That's the real secret." He moved to the ammunition bay. There, beneath the nose, was another revelation: the feed system for the 4 Browning machine guns. The belts ran through electric boosters, ensuring smooth firing even during sharp maneuvers. He traced the cables with a finger, admiring the simplicity. "Each gun has an assist motor," he explained. "It guarantees feed under high G turns. That's why their pilots can fire while climbing or diving without jamming." "Their firepower is absurd," Mancini said, shaking his head. 2,000 rounds and a cannon." Zapata looked up. "Yes, but think of what that means. Their aircraft isn't designed for duels. It's designed for efficiency. Every burst must count, every second in combat shortened." He turned toward the tail assembly, his mind racing faster than his hands could keep up. The twin booms that had once seemed clumsy now appeared brilliant. They housed the turbocharger exhaust lines, hydraulic reservoirs, and even the control linkages, all perfectly balanced. The rear structure wasn't just functional. It was architectural. "Every inch of this plane earns its place," Zapata said. "No vanity, no flourish. Every rivet does something." By midday, the hangar had grown hot, but Zapata didn't notice. He was sketching the internal framework, tracing where the aluminum alloys transitioned from high-strength to lightweight sections. The Americans had mastered selective reinforcement, strengthening only where necessary, conserving weight without risking integrity. It was the logic of abundance meeting the precision of necessity. He paused to wipe his brow. "Do you know what this is, Mancini? It's not just engineering. It's confidence. They build as if failure is impossible." "Maybe because, for them, it isn't," Mancini said. That line hung in the air. Both men knew it was true. As they packed up their tools, Zapata flipped through his earlier notes again. The cooling system, the metallurgy, the electrical redundancy. Every discovery pointed toward the same truth. The Americans weren't building aircraft as Italy did. They were building systems that produced aircraft. He remembered visiting a Fiat factory years earlier. Workers assembled engines by hand, each one slightly different from the last. Parts were filed to fit, bolts adjusted by feel. Pride in craftsmanship was everything. Now, staring at the Lightning's flawless uniformity, Zapata realized how obsolete that pride had become. The Americans had replaced craftsmanship with consistency. He returned to his desk and began another draft for his report, a section he titled simply Production Realities. Italian manufacturing remains artisanal, he wrote, relying on skilled craftsmen and manual fitting. American methods achieve interchangeability through machine precision. Every part of the P-38 is built to be identical to every other. Its engines, instruments, and wiring harnesses can be swapped between aircraft with minimal adjustment. This reflects not only technical capability but an industrial philosophy entirely foreign to ours. He paused before adding, "Our challenge is not design but reproduction. We can understand their methods intellectually, but we cannot implement them without transforming our entire manufacturing culture." By the time he finished, the sun had set again. The hangar lights flickered to life, bathing the P-38 in a soft golden glow. It looked less like a machine and more like a monument, a symbol of something larger than war itself. Zapata stood by the window, his expression unreadable. "They've built an empire into this airplane," he whispered. "And we've built art into ours. But in the end, art doesn't win wars." He didn't sleep that night. He spent hours rereading his notes, each page filled with figures that no optimism could erase. The realization was total now. Italy's engineers were fighting equations that didn't balance. When he finally looked up from his desk, dawn was already breaking again. And outside, the lightning still stood where it had yesterday, quiet, perfect, and impossibly far ahead. The morning after his sleepless night, Zapata walked across the airfield toward headquarters carrying a leather folder filled with his completed report. The air smelled faintly of fuel and sun-warmed aluminum. Behind him, the captured Lightning shimmered in the early light, guarded by two soldiers who barely grasped its importance. For them, it was just another foreign plane. For Zapata, it was the mathematical proof that Italy's future had already been decided. Inside the main building, the corridors buzzed with the hurried rhythm of wartime bureaucracy, officers pacing, clerks typing, messengers darting between rooms. When Zapata entered the briefing room, the hum fell silent. Senior engineers and staff officers turned their heads as he laid the folder on the table. "This is my full technical assessment of the American aircraft," he said simply. His tone was flat, his expression composed, but his eyes betrayed the exhaustion of a man who had stared too long into unwelcome truth. Colonel Rinaldi, a sharp man with neatly pressed uniform sleeves, adjusted his glasses. "We've been expecting it. I understand you found the aircraft impressive." "That's one word for it," Zapata replied. "Another would be impossible." He opened the folder and began walking them through his findings. The room grew quieter with each page turned. Charts, sketches, power curves, all meticulously drawn. "Each engine produces over 1,100 horsepower," he explained, tapping the figures. "Together, they sustain nearly 3,000 at altitude. Their turbocharger system compensates for atmospheric loss beyond 20,000 feet. In practical terms, they can fight where we can barely breathe." One of the officers frowned. "But our Macchi C.205s are agile. Can't agility overcome raw power?" Zapata met his gaze. "Agility only matters when you can reach the fight. At 25,000 feet, this aircraft still accelerates. No Italian fighter can even catch it." He moved to the next section. "This," he said, holding up a diagram of the cooling system, "is their thermal efficiency. Their radiators are in the wings, not the nose, using airflow to manage temperature while reducing drag. It's a system we've discussed for years but never perfected. They've done it, in mass production." Rinaldi raised an eyebrow. "Mass production?" "Yes. They produce hundreds of these aircraft every month, each with identical systems, identical performance. It's not one miracle. It's an assembly line of miracles." The words lingered in the air. Zapata continued. "Their weapons are concentrated in the nose. One cannon, for heavy machine guns. Perfect alignment. No convergence. It's like pointing a finger and striking lightning. Our fighters use wing-mounted guns, which are precise at one distance only. Beyond or below that, accuracy collapses. The P-38 eliminates that limitation entirely." Another officer tried to sound hopeful. "Surely such complexity must come at a cost. Maintenance, perhaps." Zapata nodded slightly. "Yes, it requires trained mechanics. But they have them. Their manuals are written for clarity. Their factories produce spare parts endlessly. We build with the expectation that every aircraft must survive. They build with the expectation that they can replace anything." He flipped to the final pages, the section titled Strategic Assessment. His handwriting there was smaller, more deliberate. Gentlemen, our analysis leads to one conclusion. We cannot compete with this level of industrial sophistication. Not now, not within 5 years. A heavy silence followed. Rinaldi leaned forward. Engineer Zapata, are you suggesting surrender? Zapata shook his head. I'm suggesting mathematics. The Americans are fighting with numbers, not just courage. For every P-38 we examine, they can build 200 more. For every pilot we train, they have 10. Their factories are not limited by manpower or resources. Ours are. He closed the folder. You asked for an engineering report. That's what this is. But it's also a warning. When the meeting ended, the officers left quietly, exchanging uneasy glances. Rinaldi stayed behind for a moment. You've given them reason to call you pessimistic, he said softly. I'm not pessimistic, Zapata replied. I'm accurate. He left the building and walked back toward the hangar. The afternoon sun was harsh now, glaring off the metal skin of the Lightning. He stood there for a long time, staring at the machine that had made him question everything he'd believed about engineering. By evening, copies of his report began circulating through higher command. Some readers admired its precision, others dismissed its tone as defeatist. A few simply ignored it. The section marked strategic assessment, the part that mattered most, was quietly removed before the document reached certain officers. When word reached the ministry, one senior official wrote a short note in the margin, technically sound, strategically irrelevant. Zapata never saw that comment, but he didn't need to. He already knew what would happen. The technical details would be studied, the metallurgy analyzed, perhaps even some design features copied. But the greater truth, the industrial imbalance, would be buried under optimism and rhetoric. That night, as he sat in his small office, the air thick with the smell of machine oil and paper, he stared at the blueprint spread across his desk. The P-38's profile looked more alive than any Italian fighter he'd ever drawn. He realized then that the Americans hadn't just built a faster plane, they'd built time itself. They were years ahead, and every day Italy fought, that gap widened further. Outside, the hum of the airfield faded into silence. In the hangar, the Lightning rested beneath dim lamps, looking almost serene. Zapata turned off his light and whispered to himself, they've already won, and they haven't even arrived yet. He wasn't being poetic. He was being precise. The following day dawned clear and windless, perfect flying weather. The air over Guidonia shimmered with heat as mechanics wheeled the captured P-38 Lightning back onto the runway. Word had spread across the base. Colonel Angelo Tandy would test fly the American fighter for the first time. Pilots, engineers, and even clerks abandoned their posts to gather near the hangar fences, eyes fixed on the metallic twin-boom silhouette that glistened beneath the Italian sun. Zapata stood beside the control tower, clipboard in hand, watching as Tandy climbed into the cockpit. The colonel's calm, practiced movements betrayed no hesitation. He had flown every Italian aircraft, and several foreign ones besides, but even he had confessed the previous night that this machine made him uneasy. It looks heavy, he had said, like it was built to lift a mountain. Now, strapping in, he looked more curious than doubtful. One by one, the two Allison engines sputtered to life. First the left, then the right. Their counter-rotating propellers blurred into perfect symmetry, the vibration so evenly balanced that the tower windows barely trembled. The mechanics, who were used to the sharp rattle of Italian engines, exchanged glances of surprise. It sounds like a single heart, one whispered. The aircraft began to taxi, its tricycle landing gear rolling smoothly over the tarmac. When Tandy reached the end of the runway, he paused briefly, throttled forward, and the Lightning surged ahead. The roar deepened, steady and unwavering. Then, with a long, graceful lift, the fighter rose from the ground and climbed as if gravity had forgotten it. Zapata watched through his binoculars. That's 3,000 feet in less than a minute, he said quietly. He hasn't even used full power yet. The P-38 climbed higher, banking into the sun, its silver frame flashing like a blade. Tandy performed a series of turns, dives, and ascents, each one smoother than the last. From the ground, it looked effortless, as though the aircraft anticipated his every command. 10 minutes later, the Lightning leveled off at altitude. Then, in a breathtaking dive, it streaked toward the airfield, leveling again before touching down with absolute precision. When the engine shut down, the crowd waited in silence. Tandy remained in the cockpit for a long moment, hands resting on the controls, before finally climbing down. He removed his goggles slowly, then approached Zapata without a word. "Well?" Zapata asked. Tandy exhaled, his voice low. "Everything you wrote was true. And you didn't write enough." He gestured back at the P-38. "At altitude, it keeps gaining speed long after our engines would fade. The controls are heavy but precise, like guiding a living thing that knows what it's doing. And the visibility. You can see everything. There's no blind spot." He paused, looking down at his gloves. "I fired a short burst. Just one." His voice grew quieter. "It's overwhelming. The recoil barely registers, and every round lands where you aim. It's not an aircraft, engineer. It's a weapon system." Zapata nodded slowly. "Can we counter it?" Tandy looked at him for a long time before answering. "Not with what we have. Not with what we are building. The Macchi is beautiful, the Fiat is reliable, but this thing," he searched for words, "this is from another age." They walked together back toward the hangar as the mechanics began inspecting the Lightning's landing gear. The other pilots gathered around Tandy, bombarding him with questions, but his answers were brief, measured. Stable at high altitude. No torque drift. Power like nothing I felt. When someone asked if he thought the Americans had over-engineered it, he smiled faintly. Over-engineered? No. Perfectly engineered. That afternoon, a series of test flights followed, Italian fighters against the captured Lightning. Zapata and Tandy observed from the tower as the Macchi C.205S tried to outclimb it, outturn it, or even outdive it. Every attempt failed. At 20,000 feet, the Italian engines gasped for air while the turbocharged Allisons roared effortlessly. Even the German-made Messerschmitts struggled to keep pace. The P-38 simply chose when to fight and when to vanish. In one mock engagement, Tandy allowed a Macchi to close within 500 meters before pushing the throttles forward. The Lightning surged ahead and disappeared into the clouds within seconds. The Italian pilots returned frustrated and silent. "It's like chasing a ghost," one said. That evening, Zapata met Tandy again in his office. The pilot's face was unreadable. "You realize what this means," he said quietly. "They're producing these by the hundreds, maybe by the thousands." "I've calculated it," Zapata replied. "If intelligence is correct, by next year they could be building 500 per month." Tandy gave a short laugh, though it carried no humor. 500. We barely manage 80 fighters in the same time. And that's on good months. He walked to the window, staring at the darkening runway where the Lightning rested under floodlights. "We used to think war was about pilots, about courage, skill, and instinct. But this," he gestured toward the aircraft, "this is about production. About nations that can build faster than others can fight." Zapata said nothing. There was nothing to add. Tandy turned back toward him. "Do you ever wonder how long it took them to design it?" "Probably less time than it took us to argue about design philosophy," Zapata replied. Tandy smiled faintly. "You're probably right." For a while, they stood in silence, the rhythmic chirping of distant crickets filling the air. Then Tandy spoke again, softer this time. "If I'm being honest, engineer, I'm glad I flew it. Because now I know the truth. We are not losing because our pilots lack skill or our engineers lack imagination. We are losing because they build like we dream." Zapata looked up at the stars beginning to appear above the horizon. "Maybe," he said. "Or maybe we dream too much, and they don't dream at all, they calculate." The words lingered long after the two men parted. That night, the captured Lightning sat silent under the moonlight, its polished skin reflecting the glow of a dying empire still trying to understand the future that had already arrived. Over the next several weeks, the captured P-38 Lightning became the centerpiece of Italy's most secret aviation study. Every test flight, every technical inspection, every page of Zapata's notes pushed one conclusion closer to certainty. The Americans had not simply built a better airplane. They had built an entirely different philosophy of flight. At first, Italian engineers tried to find flaws. They measured the Lightning's climb against the Macchi C.205, its acceleration against the Fiat G.55. They compared its handling to the German Messerschmitt Bf 109. But no matter what benchmark they used, the American fighter always exceeded expectations. At high altitude, Its turbocharged engines delivered consistent power, while Italian and German planes faltered as oxygen thinned. In dives, the P-38 maintained stability long after others began to shudder. In gunnery trials, its nose-mounted weapons delivered accuracy unmatched by wing-mounted guns. Every test ended the same way: silence, then a low whistle of disbelief. Zapata observed all of it from the control tower, clipboard in hand, his pencil moving almost mechanically. His reports became less about raw numbers and more about the meaning behind them. "It isn't that their engines are stronger," he wrote one evening. "It's that their industry makes strength easy." Inside the hangar, mechanics began disassembling parts for deeper study. They removed panels, unscrewed bolts, examined welds. What they found was even more astonishing than the aircraft's performance. The quality of the metal, the precision of the machining, the finish of every joint, all spoke of a manufacturing culture built on abundance. One young engineer ran his hand along the interior of a wing spar. "Every weld is perfect," he whispered, "even in places no one would ever see." Zapata nodded. Because for them, every process is the same. They don't build one perfect plane, they build thousands, all perfect. Another engineer, Russo, studied the reduction gearing assembly. The gears were cut so precisely that they glowed faintly where the steel had been hardened. "We couldn't make these," he said simply. "Not even if we had the drawings." "It's not the drawing," Zapata replied quietly. "It's the machine that makes the drawing real." By now, he knew the truth was larger than any technical limitation. It was about the culture of production itself. In Italy, innovation began in the mind of an engineer and ended in the hands of a craftsman. Every aircraft bore small variations, personal touches, even signatures of its makers. But in America, engineering was impersonal, mathematical, industrial, and terrifyingly consistent. The difference wasn't passion. It was scale. The contrast became most obvious when they examined the turbocharger. Italian intelligence had long known that American engines used exhaust-driven compressors to maintain performance at high altitude. But seeing the system in person changed everything. The turbine blades were made from a nickel-based alloy that could withstand temperatures far beyond what Italian metallurgy could manage. The casting was flawless. No pitting, no stress fractures, no visible imperfection under magnification. Zapata turned one of the blades under the light. "This spins at 21,000 revolutions per minute," he murmured. "If the alloy isn't exact, it shatters. They've achieved perfection not by miracle, but by repetition." He paused, setting the part down carefully. "We can design like this, but we can't build like this." Mancini scribbled the words into his notebook. As the examination continued, the engineers began comparing the Lightning's internal systems to their own aircraft. The electrical system used a 24-volt dual generator setup. The hydraulics were reinforced and redundant. The fuel system was self-sealing, with cross-feed options that allowed either engine to draw from any tank. It was as though the Americans had asked one simple question at every stage of design: what happens when this fails? Italian fighters had no such redundancy. If one pump failed, the system failed. If one wire burned, the circuit died. Every component of the Lightning assumed failure would happen, and planned for survival anyway. By late July, the engineers began assembling their final report. It spanned dozens of pages, filled with precise measurements, chemical analyses, and performance data. But the most important section came at the end, the one labeled Strategic Implications. In that section, Zapata wrote words that would never be printed in any official document. "We are not losing the war because of tactics or bravery. We are losing because the enemy has turned production into a science. They have replaced craftsmanship with mathematics, scarcity with abundance. Every nut and bolt in this aircraft is a reminder that they can build more of everything, faster, cheaper, and better. Our pilots fight with skill. There's fight with factories." When he finished, he signed his name quietly at the bottom. The report was sent to Rome the next morning. Some parts would be studied, others ignored. But for those who had seen the P-38 up close, the conclusion was already clear. Italy's engineers had glimpsed a world where war was not decided in the sky, but in the machine shops that made the sky conquerable. That night, Zapata walked once more through the darkened hangar. The Lightning sat silent under dim lights, panels removed, its gleaming form reduced to exposed wires and skeletal frames. Yet even stripped bare, it radiated power, not from its engines, but from the idea it represented. He rested his hand on the cool aluminum skin. "We built airplanes," he whispered. "They built the future." And in that quiet moment, surrounded by the echo of his own words, he realized that no amount of ingenuity could turn back the tide of industry. By early August 1943, the captured P-38 Lightning had become both a symbol and a secret. The Italian Air Force guarded it carefully, knowing it was one of the few complete examples of American engineering ever to fall into their hands. Yet, within the hangar at Guidonia, it had also become something else, a quiet monument to inevitability. Zapata's technical report had reached Rome weeks earlier. Officially, it was praised as thorough and valuable. Unofficially, most of its conclusions were ignored. His warnings about industrial disparity were considered theoretical pessimism. Italy's leaders still believed in courage, strategy, and divine fortune, things that could not be measured in horsepower or factory output. But on the airfield, those who had touched the Lightning knew better. Colonel Tandy was the first to say it aloud. "The war in the air is already over," he told Zapata one morning, staring at the silver aircraft as mechanics worked nearby. "It just hasn't reached the newspapers yet." A few days later, Tandy was ordered to fly the Lightning on a real mission, a propaganda effort disguised as a combat test. American bombers had been sighted returning from a raid on southern Italy. If the captured fighter could intercept one, it would make headlines. When Tandy strapped in, Zapata stood nearby, arms crossed, watching silently. He knew what the colonel was thinking, not victory, but demonstration. The Lightning's engines started with their usual perfect harmony, twin spirals of exhaust curling upward as the plane rolled to the runway. The takeoff was flawless. The aircraft climbed fast and disappeared toward the horizon. Radio chatter followed for several minutes, then silence. Half an hour later, reports came in. One American bomber down, possibly a B-24. Witnesses described seeing a lone twin-boom aircraft streaking through formation fire, firing a single burst, and then vanishing into the clouds. Tandy had done it, but the victory felt hollow. When he landed, Zapata met him on the tarmac. The colonel climbed out, eyes distant. "It worked exactly as we thought," he said. "I didn't even need to push full throttle." Zapata nodded slowly. "So we've proven it." Tandy glanced back at the aircraft. "Yes, we've proven we can borrow their power for a day, but we can't live in it." The Lightning was grounded soon after. Without proper spare parts or maintenance manuals, even minor issues became impossible to fix. The aircraft that had once symbolized technological perfection became a hangar ornament, admired but no longer operational. Weeks passed, and the war outside crept closer to Rome. Allied bombers darkened the skies more frequently, their formations stretching from horizon to horizon. Each time, Zapata looked up, wondering how many P-38s escorted them, machines identical to the one decaying quietly in his hangar. In September, Italy surrendered. When German forces moved in to secure the airfield, the captured Lightning changed hands once more. Zapata was ordered to remain at his post and assist German engineers with documentation. But by then, the aircraft had lost its magic. Its panels were stripped, its engines half disassembled. To the Germans, it was merely another study specimen. A few weeks later, during a hurried withdrawal, the remaining Italian personnel received orders to destroy all sensitive material. Zapata watched as soldiers loaded explosives beneath the Lightning's empty fuselage. He turned away before the blast, unable to watch the silver wings vanish into smoke. The next morning, all that remained were twisted fragments of aluminum scattered across the airfield. The Germans left soon after, taking what they could salvage. The hangar stood empty. For months afterward, Zapata could not bring himself to look at an aircraft the same way. Every curve of Italian design, every finely polished component, reminded him of the cold precision of the Lightning, a machine that had proven not only superior in the air but in the very logic of its creation. When the war finally ended, the numbers became public. America had built over 10,000 Lightnings, each requiring 2 Allison engines. More than 20,000 of those engines had been produced, just for that model. Italy's entire wartime output of aircraft engines, across all factories and models, had been barely 13,000. The comparison was beyond discouraging. It was conclusive. Years later, in the 1960s, a journalist tracked down the retired engineer, now living quietly near Turin. When asked about that June day in 1943, Zapata's memory was sharp as ever. "I knew the truth the moment I opened those cowlings," he said softly. Not because of the metal, or the engines, or even the power. It was because I realized what it represented, an industry so vast it could make perfection routine. They built airplanes the way we build dreams. He paused, smiling faintly. Do you know what the Americans understood better than anyone? That reliability is a kind of courage. The interviewer asked whether he ever flew in the Lightning. Zapata chuckled. No. I left that to Colonel Tandy. I didn't need to fly it. I had the numbers, and numbers tell no lies. He leaned back, eyes distant. At the time, it felt like we were losing a war. But what we were really losing was time. Years, maybe decades. They were already living in a future we hadn't even imagined. Outside the cafe window, jetliners roared overhead, the descendants of that same lineage of engineering and industry. Zapata watched them pass, and for a moment, the sound of their engines seemed to echo the rhythm of the twin Allisons he had heard so long ago at Guidonia. He smiled faintly. The Lightning, he said. It wasn't just an airplane. It was the future, landing in the wrong country. In the years that followed, the story of the captured Lightning faded into obscurity, buried under the countless official reports, forgotten airfields, and the silence that followed defeat. But for those who had seen it, the memory remained vivid. For engineer Enzo Zapata, it was not just a chapter of war. It was the moment when the future revealed itself and then vanished into smoke. He returned to his profession after the war, teaching engineering at a small university in northern Italy. His lectures were calm, methodical, and never political. Yet every so often, when discussing the principles of design or the limits of technology, his tone would change. Perfection, he would say, is not a single invention. It's a system that repeats its success. His students never knew he was speaking from experience, from the day he touched an aircraft that had been built by a nation that understood that rule. In the 1950s, Italy began rebuilding its aviation industry. Factories reopened with modern tools, some supplied by the same countries that had once been enemies. Young engineers filled the workshops, eager and hopeful. Zapata was often invited to consult. When asked how to make Italian aircraft competitive again, he answered the same way every time. Start with the factory, not the airplane. He never mentioned the P-38 by name, but every engineer who heard him sensed that he was describing something extraordinary, a ghost from the past that had set the standard for everything that came after. One summer afternoon, decades later, he visited an air museum in Northern Europe. There, under bright lights, stood a restored P-38 Lightning, polished, pristine, and impossibly familiar. Tourists walked around it, admiring the design, the twin booms, the smooth lines. To them, it was just another historic relic. To Zapata, it was a mirror reflecting the moment he first understood the mathematics of power. He walked around the aircraft slowly, tracing the contours of the metal with his eyes. Every rivet, every curve of the engine nacelle was exactly as he remembered. The display plaque listed its specifications: 1,475 horsepower per engine, 414 miles per hour maximum speed, a range of over 1,300 miles. Simple numbers to the visitors. But to Zapata, each figure carried the weight of history. He smiled faintly and whispered under his breath, "Still perfect." A young museum guide approached, noticing the elderly man's focus. "Beautiful, isn't it?" she said cheerfully. "They say it was one of the most advanced aircraft of the war." Zapata nodded. Yes, but not because it was the fastest or the most powerful. It was advanced because it was repeatable. That's what made it unbeatable. The guide tilted her head. Repeatable. He smiled. Anyone can design a masterpiece. Only a nation can build 10,000 identical ones. That evening, as he left the museum, he paused on the steps to watch the sky. A passenger jet climbed overhead, its engines roaring faintly in the distance. Smooth, fast, efficient, the culmination of everything the Lightning had predicted. For the first time in years, Zapata felt no bitterness. Instead, he felt a quiet admiration for the world that had learned from the lesson he had witnessed so long ago. He thought of Colonel Tandy, of the young engineers who had gathered in the hangar at Guidonia, of the rows of mechanics who had stared at the captured plane in awe. None of them had known then that they were looking at the blueprint for the century to come. In his final notebook, found years after his passing, one entry stood alone on the last page, dated simply autumn 1968. The handwriting was still steady, careful, precise. The Lightning was not a victory of one pilot over another, nor one nation over another. It was the victory of process, of the machine that makes machines. It proved that progress is not an act of genius, but an equation. Innovation times production times time equals dominance. Below that, he had added one final line. We lost because we believed the future could be designed. They won because they learned how to build it. Those words, simple and quiet, summarized everything he had tried to teach his students, and everything the captured Lightning had shown him. Today, in museums and airfields across the world, the P-38 Lightning still stands gleaming under hangar lights. Visitors admire its shape, its speed, its daring design. Few notice the smaller details, the perfect welds, the polished rivets, the flawless symmetry of its components. But to an engineer like Zapata, those details were the real story. Because beneath the roar of engines and the myths of heroes, history is written not only by battles, but by the factories that shape them. And somewhere, deep within that timeless hum of machinery, the echo of the Lightning still lingers, a whisper from another era, reminding the world that progress, once unleashed, never lands twice in the same country.